Hello guys, and welcome back to the reaction zone. In today's lesson, we're going to look at how to solve the question of electrolysis that's on the board. And the question is as follows. An ammeter and a copper voltmeter are connected in series through which a constant current flows. The ammeter shows 0.52 amperes. If 0.635 grams of copper is deposited in 1 hour, what is the percentage error of the ammeter? Now, to solve this particular question, we have to get the actual value or the true value of the current. And to get the true value of the current, the first thing we need to do is to find the quantity of electricity that is going to deposit 0.635 grams of copper. So, the first thing to write is the equation that shows the deposition of copper at the cathode. Now, copper ions or copper 2 ions are divalent, and they will undergo reduction by accepting 2 electrons to give 1 mole of copper or 1 copper atom. Now, the mass of 1 mole of copper is 63.5 grams, and the quantity of electricity in 1 mole of an electron is 96,500 coulomb. Now, but there are actually 2 moles of electrons here, so it means this is going to be 2 times 96,500 coulomb. So from this equation, we can actually say that 2 times 96,500 coulomb of electricity deposits 63.5 grams of copper. So we can say that if X coulomb of electricity deposits 0.635 grams of copper, then we can cross multiply at this point. And then we have X multiplied by 63.5 is going to be equal to 0.635 times 2 times 96,500. And then X is going to become 0.635 times 2 times 96,500 divided by 63.5. And this is actually going to give 1,930 coulombs. So what this means is that the quantity of electricity or electric charge that deposits 0.635 grams of copper is 1,930 coulomb. Now, we're actually told that 0.635 grams of copper is deposited in 1 hour. So, we now know that Q is equal to 1930 coulomb, and the time is what? 1 hour. 1 hour is the same thing as 60 times 60 seconds, which is 3,600 seconds. So knowing that Q is equal to height, and that therefore I is going to become Q over T, which is going to be 1930 divided by 3,600. And this is going to give 0.536 amperes. So, what this tells us is that the true value of current, or the actual value of current that deposits 0.635 grams of copper in 1 hour is 0.536 amperes. Now, according to the question, we are told that the ammeter shows 0.52 amperes, meaning that the reading from the ammeter is faulty. It's not correct. So, we're told to find the percentage error of the ammeter. The percentage error of the ammeter, the percentage error of the ammeter is simply going to become the error divided by the actual value of current multiplied by 100. And this is simply going to be, to get the error, it is going to be actual value of current minus the reading from the ammeter. So that is going to be 0.536 minus 0.52 divided by 0.536 multiplied by 100. And this is going to give us 2.985%. So, the percentage error of the ammeter is 2.985%. So I want to believe that the solution to this question is clear. Thank you very much for watching, and see you in the next one.